Hello students, this is Professor Chalai, and in this video we're going to begin to look at Chapter 9 as we take a look at gas pressure. As always, you can follow along with our Chapter 9 workbook. By the end of this video, you should be able to define pressure, convert between various units of pressure, and also calculate the pressure from a manometer. Let's begin. So as we think about gases and how they behave, I want you to imagine gases as being tiny little particles, regardless of what gas molecules they are, zipping around the room that we can't see at all at speed at very high speeds, bumping into each other, bumping into the walls of the container that it's in. In the case of a room, it's the walls of the room. And so, as we go along this entire chapter, I want you to keep this image of gases in your minds as we're going to explore the various concepts and the various properties of gases. So, keep thinking of gas as a bunch of molecules zipping around the room, bumping into each other, bumping into the walls of the room. Okay, so the pressure of a gas then would be the force that each of those molecules exert as they hit the walls of the container. So again, let's look at it. The pressure would come from the force of these molecules bumping into the walls of the container. And so the pressure then we can define as the force divided by the area of the container that it hits. And so if we're thinking about units, force is typically measured in newtons, right? The SI unit is in newtons. And area is in meters squared, right? So we have force in terms of newtons per meter squared. Newtons can also be broken down into more simpler form, and so we can equivalently write the pressure as kilograms over meters per second squared, right? Or that's also equal to a Pascal as another unit of pressure. So all three of these different units are identical. If you see them, they all basically mean the same thing. But keep that in mind. Some other units of pressure that you might come across, and I've written them here so that we're able to convert between them easily. Is one of them is the atmosphere. Basically, 1 atmosphere is the pressure of the atmosphere around you right now, and so that's a very commonly used unit of pressure, and we'll see that pop up quite a lot. Another unit you might see is the torr. That's equal to 760. 760 torrs is equal to 1 atmosphere. So this is why I've written it this way, and that's an exact conversion. So infinite number of sig figs. That's also equal to millimeters of mercury. 760 millimeters of mercury is also equal to 1 atmosphere. Another unit of pressure might be inches of mercury. To get from millimeters of mercury to inches of mercury, all we did was convert from millimeters to inches, but that gives us about 29.92 inches of mercury. You might also see PSI, that's pounds per square inches. And you might see this when you're trying to inflate your car tires or your bicycle tires, for example. You'll see a PSI measurement, and 1 atmosphere is about 14.7 PSI, right? So when you inflate your car tires to about 35 or so PSI, that's a little bit more than 2 atmospheres. And 1 atmosphere is 101,325 pascals. Remember, we defined pascals above as newtons over meter squared or kilograms over meters times second squared. So here's where Pascal comes in. Another unit of that you might come across that I didn't include here is a bar. You might see this a lot in newscasters talking about atmospheric pressures and in hurricanes and tornadoes and stuff like that. A bar is 10 to the 5th pascals, or in case you're wondering, that's 100 kilopascals. So also keep that in mind. Those are the various pressure units, and so we can use those to easily convert between units. As a practice, let's try number 1. Pause the video and try number 1, and then I'll go over it with you. Okay, so we're asked in this question to convert 132 psi to millimeters of mercury. So 132 psi, we look at our little conversion over here. To convert from psi to millimeters of mercury, we see that 14.7 psi is 760 millimeters of mercury. So let's use that. 14.7 psi, we put that on the bottom so that we can cancel that out, is 760 millimeters of mercury. We punch that into our calculator, right? 3 sig figs here, 3 sig figs on the bottom. This 760 is an exact measurement as we talked about, so we will end up with 3 sig figs, 6820 millimeters of mercury. I hope we all got that answer. There's a lot more here for practice, and we'll go over that towards the end of the video. Okay, so how do we measure pressure? Well, one of the instruments that we use to measure atmospheric pressure is called the barometer. And a barometer is simply an instrument like this where we have some liquid, typically it's either water or mercury, and we have a tube that comes out of that liquid, and the inside of that tube is a vacuum. So there's nothing else in there. And so as the atmospheric pressure pushes down on the liquid, it goes up that tube, right? And so the higher up the tube it goes, well, the higher the atmospheric pressure. The more atmospheric pressure pushes down on the tube, the higher up it would go. And for mercury, we typically find that it goes up about 760 millimeters at atmospheric pressure. And so that's why we have up here, 1 atmosphere is the same as 760 millimeters of mercury. That's how we measured atmospheric pressure using barometers in the past. For water, it would go up a little bit higher in the tube. That's because water has a lower density than mercury. But similarly, we can measure it that way. However, this only works for atmospheric pressure, right? We have to have atmospheric pressure pushing down on the liquid. To measure gases from reactions, which this being a chemistry course, we're going to certainly look at toward, later in the chapter, we need a different instrument called a manometer. It's very similarly set up to a barometer where you have your gas from your experiments coming into a tube, and then we measure how high up the tube it goes, but then there are 2 different types of manometers. There's the closed-end manometer that we see in this first image here, and then there are open-end manometers. In a closed-end manometer is a vacuum here. So all we need to do then is measure the height that the liquid goes up. Typically it's mercury or water. And so the pressure then will be measured using this equation. H is the height. So let me write that up here. H is the height. And typically, let's measure this in meters because that's the SI units for distance, right? Rho, this letter that looks like a P, is the Greek letter rho, right? RHO, and that's the density of the liquid. And so, because it's a density, typically it's measured in grams per centimeter cube, but for SI units, we want it really in kilograms over meters cube. One of the more common liquids that we use is mercury. So, and the density for mercury is, let's see, 13.6 grams per centimeter cube. And if you convert this to kilograms per meter cube, you find it's 13,600 kilograms per meter cube. So keep that in mind. And then G here, right, in this equation is the acceleration due to gravity. So that's the force of gravity or acceleration due to gravity, and that's equal to 9.81 meters per second squared. The density for water, let me just put that here. The density for water will just be typically 1 grams per centimeter cube in case the manometer contains water instead of mercury. So if it's closed end, right, we just have to calculate the height, multiply it by the density and the force of acceleration due to gravity. If it's open end, we now have atmospheric pressure pushing down on this open end, right? So if the height is negative, right, it means that our pressure was weaker than atmospheric pressure. So to calculate it, we take atmospheric pressure and we subtract out this H rho G pressure. If it goes above the beginning point, it means that the pressure was greater than atmospheric pressure, so it pushes up. And so we added that pressure to the atmospheric pressure. So those are the ways we can use manometers to calculate the pressure, either closed end or open end. And we'll keep that in mind as we go forward. Now, let's do some practice problems involving conversion of pressure. So again, try all of these on your own first. You now have all of the information that you need to do this. And then when you're done, you can unpause the video and we'll go over them together. Okay, let's look at number 2. We're starting with a pressure of 30.44 inches of mercury, right? And we need to convert this to PSI. So we look at our conversion table again. We see that 29.92 inches of mercury is 14.7 PSI. So we're gonna plug that in. We put inches of mercury on the bottom. So 29.92 inches of mercury, so that it cancels out. We said that was equal to 14.7 PSI. So if we plug this into our calculator, we should get 14.96 PSI. Technically, this should be 3 sig figs, but whenever we're using conversions, I don't like to have the conversion limit whatever sig figs we're using. Okay, let's look at number 3. We're converting 23.8 inches of mercury to kilopascal, right? So 23.8 inches of mercury is what we're starting with. According to our table, or equation rather, we see that 29.92 inches of mercury is 101,325 Pascal, and we know that kilo means 1,000, so we can use all of that. So let's see. We talked about how 29.92 inches of mercury, so that cancels out, would be equal to 101,325 Pascal. And we know that 1 kilo, not kilogram, just kilopascal in this case, would be 1,000 pascals. So this will give us our answer in kilopascals. If I plug all of these into my calculator, I think I get 80.6 kilopascals. All right, let's look at number 4. Number 4 is using a manometer to measure the pressure of a gas. So try to see if you can answer it using what we talked about up here and the equation for, in this case, number 4 is dealing with a closed end manometer, so there's no atmosphere in there at all, so we don't even have to worry about atmospheric pressure using this equation. We talked about the density of mercury and acceleration due to gravity up here. All right, so at this point, your first step into calculating, figuring out these sorts of questions is to convert everything into SI units. So let's start with the height, right? They tell us that the height here is 26.4 centimeters, but in SI units, we want to convert that to meters, and we know that 100 centimeters is 1 meter. So this should give us 0.264 meters. The material in here is density, the material in the liquid in the manometer is mercury, and so the density, the density of mercury, we looked at above, we said was 13.6 grams per centimeter cube, which is 13,600 kilograms per meter cube, which is the units we want to use. So 13600 kilograms per meter cube. And the acceleration due to gravity, let's use green, G is 9.81 meters per second squared. So before I go figure out any of these units, let's figure out what this would amount to. So we know that the pressure should be equal to H times rho times G. So H is 0.264 meters. Rho is 13600 kilogram per meter cube. This is why we convert everything to SI units so that we can cancel out units easily, as we'll see in a second. And acceleration due to gravity is 9.81 meters per second squared. So let's see. This meter will cancel out with one of the meters, so we'll be left with meters squared. and then another meter will cancel out with this meter, and we'll be left with meters, just meters in the bottom there. So our final units will be kilograms over meters per second squared, or per meter per second squared, right? Which, if we go back all the way up here, we see that that's the same as a Pascal. So we can change this easily to pascals, right? So if we plug this into our calculator, we see that, let's see, what should it come out to? I believe it should come out to 35200 pascals. So that's the answer for B, 35200 pascals. If you wanted to convert it to torrs or bars, we know how to do that, right? 35200 pascals. We know that, let's see, 101,325 pascals from the equation above is 760 torrs exactly. So if we punch this into our calculator, we should get 264 torrs. And then to convert it to bars, we have 35200 pascals. And then we said that 10 to the 5th pascals is 1 bar, right? So that would be equal to 0.325 bars. All right, let's look at number 5. It's another manometer question. This time it's an open-end manometer. Try to see if you can answer this one on your own, and then you can unpause the video and we'll go over it together. Okay, so let's look at number 5. The height here is 13.7 centimeters, but again, we want this in meters, so we just, divide by 100 to give us 0.137 meters. The density we know is, well, I forgot what it is, so let's look up here. 13600 kilograms per meter squared. 13600 kilograms per meter squared, because it's mercury, right? If it's water, it'll be different. And then the acceleration due to gravity is 9.81 meters per second squared. So this is an open-ended manometer, which means we have atmospheric pressure pushing down on it. The pressure of the atmosphere is, well, 1 atmosphere, right? So what we need to do, if we look at this, it goes above where it started, which means it's pushing up against atmospheric pressure, which means that the overall pressure is larger than atmospheric pressure. So the pressure should be the same as the atmospheric pressure plus whatever this H rho G turns out to be. So let's calculate H rho G. Let's calculate this pressure, H rho G. That will be equal to, H is 0.137 meters. Rho is 13600 kilogram per meter squared. G is 9.81 meters per second squared. And we know that that all comes out to be pascals. And so if I multiply all of this, I get 42300 pascals. Okay. Now, to get the total pressure, we need to add atmospheric pressure to that. So the pressure will be atmospheric pressure, which is 1 atmosphere, plus 42300 pascals, right? 1 atmosphere here is the pressure of the atmosphere. There we go. So to add these two up, we need to convert them both to the same units. And so let's convert both to atmospheres. So the pressure will be 1 atmosphere plus, let's convert 42300 pascals to atmosphere. And to do that, we know that 1 atmosphere is 101,325, I think, pascals. And so that this whole part here comes out to be 0.417 atmospheres. So this total thing becomes 1.417 atmospheres, which is the answer to B, 1.417 atmospheres. Now you can convert that to millimeters of mercury and kilopascals. I'm not going to go over those for you because you've had lots of practice. But if you do run into trouble, please let me know. So that will bring us to the end of this video. In this video, we talked about gas pressure. We talked about how the pressure is the force that the molecules exert when they hit the container that it's in, whether it's the room or your body, right? That's the wall of a container. So the pressure you feel is the pressure of gas molecules hitting into you. We talked about various different types of pressure units, including the atmosphere, which is the pressure of the atmosphere, the bar, which is the pressure that a meteorologist uses when they talk about atmospheric pressure sometimes. And there's other ones like PSI is the pressure in your car tire, the units they use for pressures in your car tire, for example. We talked about the barometer and the manometer. Barometers are used to measure atmospheric pressure only. Manometers can be used to measure pressure of gases from like chemical reactions, for example. And we went over a lot of examples on how we can use these in various calculations. In our next video, we're going to talk about other properties of gases, including volume, the amount of gas, the temperature of the gas, and how that all relates to the pressure of the gas. We'll see you then.